Right. Hello, Miss. My name is Taiken Sonto, and NIM 2023-012-0059, and I'm here to demonstrate the simulation or a schematic capture of the Kirchhoff's voltage law. Uh, before we dive into the before we delve into the simulation process, I want to explain. Kirchhoff's voltage law states that all the sum of voltages entering or entering into the closed circuit must be equals zero because all the voltages rising must be equal to the voltage dropping within the second. So when we place 12 volts into the circuit, all the resistors will get the voltage drop must be equal to this voltage in, so that this voltage will be zero. So with that information, let me get the resistors first. Resistor, get this 6, and then this 120 ohm resistor. We place it around here. The other one, and this is the other one. Okay, we have the three resistors, so we will connect in series all these resistors. Connect them in series. Mhm. Okay, so resistors are connected in series. Here we will we're gonna wait a sec. So now we will get the battery source, the power source. It will be power source will be DC. The voltage rising, this one, and we will place it over here. Yes, and connect it. Mhm. So this is the battery source. This 12 volts. So let's change it to 12 volts. 12 volts. So when this 12 volts entering this resistors, the resistors will be these resistors will have the voltage drop of these 12 volts. So all the voltage will be equally shared among these three resistors. So let's change this to 120. Let's say this is, let's say this is 100. Let's say 100K, and this one is let's say 80. Yeah, 80K. So when this voltage here is when it power is dissipated through this, the voltage will be shared among these three resistors. So in order for this to become the complete circuit, we will need a ground to complete it. We will need a uh, ground, not this one. Yes, you put the ground here and connect it. So now we will get the voltmeters. voltmeters, AC voltmeter. So AC voltmeter must be connected in series, in parallel. Only the ammeter is connected in series. So let's connect this. Yes. Hmm. So here we go. Mhm. So as you can see, so this one is 17, 7.2 volts. This one is 0 volts, and this one is 4.80 volts is going into the power is dissipating through these two resistors. So let's change this to wait. The other one is 0, so let's change it first. Let's change this. Change that to. Oh wait a sec. Let's change it to 90k and see. Uh-huh. So when the 12 volts is dissipated through this, as we can see, these resistors get this resistor get 120k resistor get 4.96 volts, and 90 get 3.72, and the 80 get 3.31. So when you add all of this is 710, 10 plus 31, 72, and this one is 10, it's 2. So it is 12. So all the 12 volts is dissipated through these resistors, and all these resistors have the equal amount. So there is nothing coming out from the end. So that confirms that the Kirchhoff's voltage law states that the sigma of all the voltage is equals to 0. So that's confirmed. So it's a confirm. Thank you, and that's all.